The next topic is called growing annuity and growing perpetuity. This is like a little bit more complicated, well, probably a lot more complicated, right, than what we just did. So think about the cash flows in our annuity or perpetuity being not constant, but instead growing, but following some pattern. They're growing at the same rate every time period. For example, a growing annuity. What would a growing annuity look like? Let's say there are 4 annuity payments. So normally we would say that they are the same amount, right? But now we are saying that the first annuity payment is this much money. The next one is some percentage larger. So to find it, we would take C and multiply by 1 plus G, where G is the percentage increase. Then the third one will be larger again. So we can change the power to 2, right? C multiplied by, open parenthesis, 1 plus G, close parenthesis, second power. And then the fourth one in our growing annuity will be calculated the same way, except the power would be changed to 3. There is a way to simplify this whole thing, and it actually looks a lot like the present value of a regular annuity, except we have the growth rate in the annuity payments reflected in the formula in a couple of places. So you would do the annuity cash flow, C, multiplied by the fraction with 1 on top and on the bottom, R minus G. Then you multiply by, open parenthesis, 1 minus, the term raised to the power T has on top 1 plus G and on the bottom 1 plus R. And you close the parenthesis. Unfortunately, you probably expect me to say, don't worry, we can solve it in the financial calculator. No, not this time. This time I'm going to tell you that this could only be done by hand. This is probably the most complicated formula you will see in this class. No, actually there will be one more, but it's okay, I'm not going to scare you with that yet. At this point, this is the most complicated formula in this class, and you have to use it by hand, unfortunately. Future value of a growing annuity. Technically, there is a formula to find the future value of a growing annuity, but it's not in the book and we're going to skip it, so don't worry about it. Present value of a growing perpetuity, where the perpetuity payments are growing at the same rate over and over and over forever. Again, we can start with the present value of a perpetuity formula that we had earlier, which had C divided by R. And now the way we adjusted for the growth in the cash flow amounts is on the bottom where you used to have R, you now have R minus G. So that's it. So you have C divided by R minus G on the bottom. The only little rule with this formula is that R must be bigger than G. Otherwise, let's say R and G are equal. Then on the bottom you have 0, and you cannot divide by 0. Or if the growth rate in cash flows is higher than the discount rate, then on the bottom of the formula you'd have a negative number, and dividing by a negative number would give you a negative perpetuity value, which kind of doesn't make sense. It's like it costs a negative amount of money, right? So you don't pay some money for it, but instead somebody pays you to buy it. So it kind of becomes a nonsense. So R must be bigger than G. That's the only little rule. For the purpose of this class, it will never come up. In all problems on growing perpetuity, your R will be larger than your G. So this issue will never come up. By the way, you might be wondering why I never talked about the future value of a perpetuity or a growing perpetuity. That's because uh, in the future, and by future we usually mean when everything ends. So when does a perpetuity end? It never ends. So if you imagine some point of time after 1,000,000 years where this perpetuity supposedly ends, even though even that is kind of a wrong thing to say, then by that time, each cash flow will earn so much interest and interest on interest that each will turn into a perpetuity, like infinitely much money. And you have infinitely many of those, infinite amounts of money. So we never actually talk about future value of a perpetuity or a growing perpetuity. It's just going to be an infinity. Let's look at this example. Your grandfather left you an inheritance that will provide an annual income for the next 10 years. You will receive the first payment 1 year from now in the amount of $3,000. Every year after that, the payment amount will increase by 6%. So this is how you know it's a growing annuity. The question in this problem is, what is your inheritance worth to you today? So the question is asking you to find the present value. If you can earn 9.5% on your investments. So we need to find the present value of a growing annuity, with the first annuity payment being $3,000 and every payment after that, so another 9, increasing by 6%. You need to use the formula where you plug in the numbers and solve it by hand. So 3,000 times 1 over 0.095 minus 0.06. Then you multiply by the whole thing by, open parenthesis, 1 minus fraction to the 10th power, where in the numerator you have 1 plus 0.06 and on the bottom you have 1 plus 0.095. The answer you get, or should get if you did everything right, is $23,774. So this is the value of this inheritance in today's dollars. Let's summarize what we have learned in this chapter so far. We looked at multiple cash flows, present value and future value. Then we looked at a special case of multiple cash flows when all of them have the same dollar value. So they're the same amounts of money. That's an annuity. An annuity is defined as identical cash flows, regular frequency for a limited amount of time. We looked at how to find the future value of an annuity for an ordinary case and annuity due case. Then we looked at how to find the present value of an annuity, ordinary annuity versus annuity due. Then we had several examples on computing annuity cash flow, which is PMT in the financial calculator, annuity interest rate, which is IY in the financial calculator, or instead the number of annuity payments, which is N in the financial calculator. A special case of annuities is a perpetuity. That's when we have an annuity that never ends. So cash flows keep going forever, right? They last forever. We only looked at how to find the present value of a perpetuity, because the future value of any perpetuity would be an infinity, an infinitely large number. So we never even have examples on that case. But we did have an example on finding the perpetuity payment when we do know the annuity present value. Another problem would be solving for perpetuity interest rate, which is IY in the financial calculator or R in the formula. For perpetuities, using the formula by hand, which is PV equals C divided by R, is much easier than doing the math in the financial calculator. In the financial calculator, what do you use for the number of payments? Technically, it's infinitely many payments, but if you just put a few nines, let's say 999, then you will get your answer. It's gonna work. And lastly, we looked at special cases of annuities and perpetuities, which are called growing annuity, growing perpetuity. That's when the cash flow amount is growing at a certain rate every time period. We only looked at the present value formulas for growing annuity and growing perpetuity. There are future value formulas, but we are skipping them.